Hi there, welcome back. Today we're gonna talk about forces and motion, Unit 1, Lesson 1, types of levers. Let's start. Are you ready? Great. We're gonna recognize the meaning of lever and also show structure of lever and differentiate between first, second, and third class lever. Let's start. To lift a heavy object, we must do work, right? But work can be easier if we use a tool to save the effort and also save time. The Greek scientist called Archimedes described lever, which is a simple machines that help man to perform heavy tasks more easily. Let's see it. If you try to lift a large rock, as in the picture, you will find that the second way will be easier. Why? What do you think? Yes, that's right. It will save time and effort. But what is this? It's a type of lever? Yes, it's lever. It's an example of lever. What is meant by lever? Lever, it's a rigid bar, straight or curved, that rotates around fixed point. Fixed point called fulcrum. And it's affected by two forces, which are effort force and resistance force. As you can see, I can say that it's a type of lever according to the position for the parts of the lever. For example, the first class lever, we're gonna see that the middle position will be fulcrum. In the second class, resistance at the middle. And the third class, effort force. So let's see how we can know the types of lever according to the middle position. So of course we have three types right now: first, second, and third class lever. And according to the middle position, we're gonna know which type the lever is. Here is the structure of levers. Any levers consists of three parts: effort force, which is affected by the person, and resistance force, which is the weight of the body that we can move it, or that we want to open it, that we want to increase its speed, whatever. And also fulcrum. So R, resistance, F, effort force, O for fulcrum. Here are some examples of levers: wheelbarrow, scissors, nutcracker. But what are the function of levers? Number one, increasing force. The example of increasing force, nutcracker. We put a small force to make great effort, as moving heavy loads, or that we use it to break the nut, as in nutcracker. And also increasing distance. The example is manual broom. Your hand moves a small distance at the upper part of the broom, while the lower part moves longer distance. So we put small, or we move the manual broom small distance, and the lower part will move longer distance, so it increasing the distance. This is number two. Number three, increasing speed, like hockey bat. Also, it moving force from one place to another. The example is manual broom. The force of your hand moves from one place to another to collect the garbage without bending. So manual broom is an example of two things. Number one, increased distance. Number two, moving force from one place to another. Also, Accuracy in performance. It's the function for levers. As tweezers, we use it to pick up very small objects. Also, avoid dangers like coal holder, ice holder. So we use it to pick up the hot and cold materials. So as we said that the types of lever, it classified according to the location of the middle position. If it effort force, it will be third class. If it resistance, so it's second class. If the fulcrum at the middle, it will be the first class. The first class lever, it's the most popular type. As you can see, fulcrum at the middle, here is resistance, here is effort force. The example is seesaw. Here is fulcrum, here is resistance, here is force. Also scissors. Here is fulcrum, here is resistance, here is effort force. The second class lever at the middle, resistance. So the example is nutcracker. And as I said, it's the load. Resistance or load, the same. So here is fulcrum, here is resistance, and as you can see, I hold it from here, so here's the effort force. The third class lever, the effort force will lie between fulcrum and resistance. So anything that you will hold it from the middle, it will be third class. Give me examples. Right, sweet holder, and also tweezers, manual broom, also fish hook, as you can see. Okay, let's compare between types of levers. First class, fulcrum between R, F, resistance, and effort force. Second class, it's a type of lever which resistance is between effort force and fulcrum. And the third class, it's a type of lever which force is between resistance and fulcrum. So first class, FOR, second class, FRO, resistance at the middle, and third class, RFO, effort force at the middle. The example is tweezers, and second class, the example is nutcracker, and for the most popular type, which is the first class lever, crowbar, scissors, seesaw, whatever. Now it's your turn to define the type of lever. Take a look at this example, the bottle opener. What do you think? We're gonna hold it from here, so here is effort force. And we're gonna put the bottle here, so here is resistance. And we're gonna fix it from here, so here is fulcrum. So effort, resistance, fulcrum. So it's second class because resistance is between effort and fulcrum. Great. Next example, seesaw. It's the most popular type. What do you think? Here is fulcrum, here's resistance, and here's effort. That's right. It's first class. Next example, the fish hook. Here is resistance. That's right. And here is effort force, and here's fulcrum. So effort at the middle, it will be third class. Super. Next example, hold it from here, right? So it's effort force. And here is the load, which is resistance. And here is the fulcrum. So resistance at the middle, it will be second class. Manual broom. What do you think? Here is effort, here is fulcrum, here is resistance. So effort at the middle, it will be right, third class. Super. As you can see, the lever rotates around the fixed point called B, fulcrum. That's right. It's a rigid bar that rotates around fulcrum and affected by an effort force and resistance force. What do you think? It's lever or solution or mixture or friction force? Super lever, that's right. Any levers consists of resistance force, effort force, fulcrum, A, B, and C. Yes, that's right. It's D, A, B, and C. All the following are from the importance of lever except increasing speed, increasing size, increasing force, accuracy, and performance. A, B, and C are correct, so I will choose C, increasing size. Which of the following levers are used to avoid danger? Avoid danger. What do you think? Coal holder or scissors, seesaw, manual broom? What do you think? That's right, it's A. Next question. In the first class lever, the midpoint is fulcrum. That's right. I hope with my video lessons you will discover how much fun science can be. Thank you for watching. Goodbye till next time.